Thank you, Rachel. So before we begin, I would just acknowledge that UBC's Point Grey campus is located on the traditional, ancestral, and ceded territory of the Musqueam people, and the Okanagan campus lies on the ceded territory of the Silex people. For today's sessions, we're going to go over an overview of what ARC, Advanced Research Computing, and the services we offer, and also the Digital Research Alliance of Canada, also known as the Alliance, and touch on how you can get an account, access to the resources that they have, and also the services and tools available. So what is UBC ARC? UBC ARC, or Advanced Research Computing, is institutionally dedicated free services for researchers across all disciplines at UBC, working with big data and solving computationally intensive questions. We are part of the UBC VPRI portfolio, so that's the VP of Research and Innovation. And why the session is both ARC and Alliance is how are we related? So ARC team members, as you may have noted from Rachel's introductions, have Alliance affiliations as well, working with various national teams, including support, cloud, bioinformatics, and many others. We also work closely with the Alliance on training and education, and also helping researchers access the resources available through the Alliance. So at UBC ARC, the operation team, we have 3 operational teams. We use this as a sort of a structure to kind of overview of what kind of support the ARC offers. The first team we're going over is Research, Innovation, Solutions, and Engagement, where the team provides expertise and user support to the UBC research community on ARC systems and provide consultations and access to the digital research infrastructure. We'll touch on what that is in a little bit. So some examples include access to these resources, grant consultation, including CFIF, so the infrastructure funds, and also the JELF. RAC consultations, we'll definitely touch on that in a little bit as well later in the presentation. And general consultation, how to incorporate these resources into your research workflows, for example, and the training on the use of DRI. How do you use these resources? The next team is the Research Infrastructure and Operations. So they provide expertise, service delivery, and operational support for digital research infrastructure, DRI, such as high performance computing, data storage, cloud computing, and high-speed network. So some examples include access to DRI, help researcher house and manage, help the university house and manage DRI, technical consultations, so pilot new and emerging technologies, such as the cloud, and also the university data center. And last but not least, the Research, Cybersecurity, and Compliance team. You may, if you have attended their session, I believe a couple of days ago, they're a team of cybersecurity and privacy experts dedicated to assisting researchers in establishing good privacy and security practices while meeting compliance requirements. So their support includes security awareness training, so aware of what are the best practices, what are those, what may be the institutional requirements, and so forth. Supporting or doing a security threat assessment, which may be requirements for various research projects, and providing privacy and security consultations. So that's an overview of how, UBC Advanced Research Computing and the services we provide. Next, we'll go over what is the Alliance, or the Digital Research Alliance of Canada. So Digital Research Alliance of Canada it's a nonprofit that is federally funded to help provide infrastructure for researchers in areas such as advanced research computing, ARC, research data management, RDM, and research software. As part of that as well, there are regional partners within Canada, including AceNet in the Atlantic provinces, Calcul, Quebec, Compute Ontario, and also various groups within the Western Canada. So what are the roles of these regions or regional partners? They coordinate local activities such as training, staff management, ensuring needs of institution provinces are being met. So they're help facilitate training and help researchers get up to speed to certain technology to help them with their research. But note that Western Canada does not have a regional organization, but we do work collaboratively with other institutions across the provinces. What is the role of the Alliance? The Alliance provides a leadership role at national scale for national scale initiatives such as resource allocation competition, procurement, coordinating research data management, and other national services. So part of what today we're going to go over is how can we help you? So some of the resources and services that we provide support for, whether it's through the Alliance or through UBC Advanced Research Computing, includes Nixcloud. So that's like a Dropbox-like data sharing, data storage platform. Globus File Transfer. There was a session about that yesterday. IaaS, which stands for Infrastructure as a Service Cloud. So essentially, it's a service through the Alliance where you could launch virtual machines or web servers or some of the other terms that you may have heard of. Stable and secure data storage and backup. High performance, big data and GPU computing and storage. So if you have analysis that would take forever or take a very long time on your personal workstation, it may be a good fit for you to run analysis on these infrastructure. Research data management, how best to manage your data from beginning to end, from collection, analysis to archival, and research software. Some of the expertise that we as a offer includes consultation, which was mentioned earlier in a couple slides back, helping to help researchers determine what resources are required, designing, optimizing, and troubleshooting workflows. So you have access to resources, how best to optimize these resources for your research, installing, operating, and maintaining advanced research computing equipment, and cybersecurity. And last but not least, training. So training are provided as a group or individual training from novice to advanced. And there's a link where you can get started just as a very, very introductory information as well, how to get started with these resources. So through the Alliance, to get access to these resources, you would need to first register for an account. So you go to that website there, ccdb.alliancecan.ca. If you don't have an account yet, and click register, and then as a principal investigator, you could fill out that form and get an account and automatically get access to some resources. For your lab members, you could then sponsor them their accounts, and they can also use the resources allocated to you. So I sort of left it vague on what resources. So by default, as principal investigator eligible investigators, they have access to what is called RAS, so on demand for smaller jobs. So as soon as you have access to your account, you have access to all the high performance computing clusters across the country. For typically runs very well with smaller jobs, larger jobs as well, and you can start running your analysis on those clusters. Cloud, I will go on to that a little bit, which is not as immediate, but we'll get to that. And rack. So you get access to the RAS or for these smaller jobs, and you may reach a certain limits in terms of it may be a long queue time, or the resources available to you may not be enough to run your analysis because your data set has grown. Then you may then consider applying for the rack. So this competition runs every fall, typically opens at the end of September, beginning of October, and then runs for about 4 to 6 weeks. And where you could apply for additional resources that's allocated to you if you that is awarded typically in the spring of the next year. So cloud RAS. So I mentioned the high performance computing RAS or a quick access. Eligible investigators, the principal investigators get access to that as soon as their account is approved and created. Immediately you have access to all the high performance computing clusters across the country. Cloud is not as immediate. You have to complete the form at the link listed on the slide there and request for access. So there's 2 types of resources you could request for. So compute instances are for short-term uses. So you could right for running analysis or running a prototype of analysis that requires a lot of memory. Persistent instances are intended for researchers that would like to set up their data portals or web applications for their research, or research tools that require a web server that you may not want to have sitting under your desk. So eligibility, rack eligibility. I mentioned principal investigator. What does that who's eligible for that? So the PI has to be, and this applies to the eligibility for the rack, the competition in the fall, runs every fall. The principal investigator, the co-PIs, has to be faculty members at a Canadian academic institution and have an active alliance account with the academic PI role. So which includes faculty members, adjunct faculty, or even librarians. So each PIs are eligible to apply for one application a year, but they could be co-PIs for additional applications. Something to note that's very important, departmental applications would not be accepted. So that's where sometimes departments where a group of researchers may want to work together and they're like, I would like to apply for one allocation for the department. Those aren't going to be accepted. It's best to apply with a PI and co-PI with a project in mind to apply for that resources. And another note is if the resources available to you through the rapid access service is sufficient, you do not need to submit for a RAC application. You can continue using the rapid access service resources available to you. Just to give you some understanding of what that RAC results looks like. So this is the results of from the past year. So this is the one competition that ran that was open last fall in 2024. The resources are allocated. This year's a little different because of the infrastructure refresh, but essentially these are the resources allocated this year. So this is for CPU, so that's the compute. This for the first year because of the additional hardware that's installed in the various data centers across the country. For the first year since a long time, that the amount of compute requested is actually less than what's available. GPU, it's a little different. So for GPU, the requested actually is more than what was available across the country. So this is what's been awarded, is about 30%, 31%. And storage, similar to the compute, storage requested is actually less than what was available. But that, as you can see, trajectory that could change as we go forward. And with that, do you have any questions? I might pass it to my colleague Venkat to go over the rest of the services.
Thanks a lot, Michael, for that good presentation. Hopefully everyone can hear me okay. And yeah, if there are any questions, I'm sure they're being collected on Slido. And we got a couple of, actually 3 folks here in person. So feel free to interrupt because I think we got a smaller group. So we're definitely willing to answer a whole bunch of questions if you have any specific ones. Otherwise, I'll keep going on. So yeah, Michael gave a really good overview of what the results are. And this is a pretty special year for the Alliance because he mentioned the infrastructure renewal that's taking place. So it's a multi-million-dollar renewal that is actually quite a bit overdue because systems have been running. It's about 2016, 2017, some of the newer ones since 2019. But essentially, almost all the computing hardware, whether it's GPU, CPU, storage, is being rebuilt from scratch and installed at the various host sites, which are at SFU, Waterloo, McGill, and a few other places in Canada. And the net positive of this is, other than for GPU capacity, this is the first time in years that the amount of requested storage and the amount of requested compute, actually, we have a surplus of capacity. Pretty amazing. So yeah, if you have CPU-bound jobs and you need a bunch of storage, feel free to start using these systems and request. I believe the rack allocations for the past year, the ones that are already awarded, will be implemented on July 31st. So if you're part of a lab that requested a rack, those allocations are going to be available really soon. So I think it's a good time because it's the first year, if you've actually started using these systems, you're going to see a huge performance improvement over previous year systems. GPU, I mean, with the AI trends and everything going on right now, that's always a concern, is GPU capacity and the amount being requested just doesn't match. But the new GPUs are a lot faster. They're the latest NVIDIA GPUs, way faster than the old ones that are a few generations old. So I think this is a great time to actually start using these systems and getting familiar with them if you have computational problems or even just storage. It's all free stuff, right? So there's no charge. I think you might have mentioned that already, but I think it's always worth repeating. Like, all these services don't cost any money. So even if you just want to try it and see if you can help, you're not being charged for it. And the actual dollar value, yeah, if you went with a cloud provider, a commercial cloud provider like AWS or Azure, you'd be paying, tens of thousands of dollars to use an equivalent amount of compute. So it's a huge value propositions that's provided by the Canadian federal government, essentially. And I think it's pretty interesting because in a lot of other countries, like most notably the States, there is some national infrastructure like the NSF provides, but there's nothing as coordinated and as comprehensive as this in a bunch of other places. There, it's usually more at the state level, similar to the provincial level, but here it's provided at the national level, which is pretty amazing. All right, so what do you have access to? So the first thing, and I know Michael also mentioned the differentiation of these, is the cloud and the compute clusters. So I'll start with the compute clusters. So these are your traditional high-performance computing systems, batch processing for large computational jobs. And I think if you attended the introduction to the HPC course earlier the week, you probably got an idea of what HPC is and what you can do with it. So essentially, when you hear the term a compute cluster or a HPC system, this is what it would refer to: a system with several, hundreds or thousands of compute nodes, thousands of cores, some storage, RAM, GPUs, et cetera, that you submit batch jobs to that run for a certain time frame and print out a result at the very end. So there are several systems available. The number of systems is actually increasing. This list will probably change at the end of July as the new systems come online and some of the old systems are taken offline, although some will be kept around for a little bit just to ease with the transition. So just the list, I'll just read this off. These are all the general purpose computing. You can see at the end, there's something called large parallel. I'll get into that in a second. But most of the systems that are available on the HPC side are what's called general purpose systems. That means regardless of what science domain you're in, you might be in bioinformatics, you might be in physics or computational chemistry, something like that. These systems are designed to support all those use cases. So they have software that's already pre-installed. You can install your own software, but pre-installed to let you take advantage of the tools you're familiar with, like MATLAB, Python, various bioinformatics toolkits like BioPerl, et cetera. So general purpose systems means they try to accommodate as wide a variety of use cases as possible that you can run on these systems. So they're not restricting you to certain types of workflows. All right, and the main ones right now are Beluga, Cedar, Gram, and Narval. These are the 4 current HPC systems that are available. There's also a specialized system called Niagara, which I believe is for large parallel jobs. What that means is if you have jobs that require thousands of CPU cores, your jobs can be parallelized. That can take advantage of, I think the minimum core count is 1,024 that you can request those. Certain types or certain classes of problems benefit from a large parallel system. But let's say you even have something that doesn't fit that. You could just want to run on a single core. A single core on these systems is way faster than what you have on your laptops, your desktops in the lab, because the processor frequencies are much higher, the RAM bandwidth is much higher, and so forth. So even if you're not running large parallel jobs, you can still benefit from using these systems. If, let's say, your laptop or your lab's desktop equipment is not fast enough and you want to see, can I get a speed boost from running on these systems? And these are some of the new ones. So those are the existing systems, but these are the systems that are currently being installed. FIR, that's the replacement for Cedar. NIBI is the replacement for Graham. And Rorcal is the replacement for Beluga. And Trillium is the replacement for Niagara. But similar type of mindset is that one is a large parallel system for parallel jobs or embarrassingly parallel problems. The other one is for just general purpose compute. And I think the key note is even if you've already used the existing systems, if you start using the new ones once they're available at end of the month is the ETA, you'll actually see a significant performance increase because it's about 5 to 6 years of advances in GPU, CPU, memory technology, right? As you guys know, in computing terms, 5 to 6 years is an eternity. So I think this is great. And hopefully it stays on a refresh cycle of 5 to 6 years going forward. All right. So with each of these systems, access, as Michael alluded to, you apply for the account under your PI sponsorship. If you are a PI, you can apply without sponsorship, and then you can sponsor users in your lab. There's no limit to the number of users you can sponsor, and the users are not restricted to just Canada. You can sponsor collaborators from any country in the world. There's no restriction as long as you authorize that usage, because essentially you've accepted the terms and conditions of the service. Storage is one big use case. There's a lot of storage that's provided on these systems just with the default quotas. You can request more using the rack competition that Michael mentioned earlier, but just by default, you get 50 gigabytes in your home drive. You get 20 terabytes in your scratch space. And what scratch space is, it's just a high-speed parallel file system for storing temporary data and computational results. And your project space, by default, you get 1 terabyte, but you can actually request up to 40 terabytes of project space. And project's a little bit different from scratch because it's backed up to tape. So you can request backups. Different sites have different policies, but 30 to 90 days is the typical retention period of those backups. So even if you weren't doing compute, but you needed a place to store data, store results, maybe share that data with other researchers using Globus, which is our file sharing service, it's quite useful for that. And all the systems offer this similar type of setup. All right. So that's I guess, the gist of the HPC. Obviously, there's a lot more. This is just scratching the surface. Cloud is the other one. Now, cloud is a little bit different from HPC in that cloud assumes you have some level of systems administration or technical knowledge because it's provided as infrastructure as a service, right? Whereas HPC, I would say, is more a platform as a service type system, even though it's not generally called that, because all the software is pre-installed. All you do is write a little script and you submit a job, it runs. You don't manage the storage, you don't manage the hardware, et cetera, et cetera. Whereas in cloud, you actually essentially take on the role of a systems administrator and you manage what's called virtual machines. So these are machines, why they're called virtual machines, where you can think of it as like your laptop, but you virtualized it and created a virtual copy of that in the cloud. But you still have to install the operating system, you have to install updates, run things. Why would somebody want to do that? If you have a use case that doesn't fit well with the HPC systems, like for example, I want to run a web server. My lab has written a web app for sharing data and I want to run it. You wouldn't run that on an HPC system because that's a batch processing, right? You'd want something to be running all the time. So the cloud makes sense for doing that, but you'd be responsible for maintaining that web server. Just an example. I want to run certain types of databases that are not available on the HPC systems, and I want to make them accessible via web interface. That's probably one of the most common use cases of the cloud systems. But once again, you have to have that system administration expertise, or somebody in the lab needs to have that to take on the responsibility of that. All right. The other thing that the cloud offers, which doesn't need system administration expertise, but is somewhat useful, is what's called object storage. So object storage is essentially just a publicly accessible URL to some backed up storage that you get if you want to share a static data set, or let's say I want to do a static website. that doesn't need a web server. I can just put an HTML file there and serve it. So not all the sites have object storage. Arbutus, the largest site, has it, but it's fairly useful for a certain number of use cases. There are other clouds too, like Beluga, Cedar, and Graham. These are typically co-hosted with the HPC systems. Reason why that's done is, let's say you have some data on the HPC that you want to access via some custom application running on the cloud. You want to have that close by so that there's no latency in the data transfer. But cloud is a fairly large topic. I know this year we didn't have a cloud course like we did last year, but there's a lot of documentation available. And yeah, I encourage it. Is there a question? No? I guess somebody said unmuted mic. If there's a question, feel free to post in the Slido, and we can answer that question live right now. Okay.
Will Cedar and Beluga be decommissioned at the end of this month when the new cluster will come online? I think I missed that detail.
Yeah, so the system should still be available, at least from the login perspective. This is as far as I know. It's a little bit, things can change, but there will be communications about it. The storage currently right now is shared between the new systems and the old systems. So you should still have the same project space, the same home directories available on both the old system, Cedar and Beluga, and the new systems, Rorcal and Fur. One thing that probably will change is, yeah, the Scratch. So there'll probably be some opportunity to migrate data off the Scratch storage. They haven't announced that yet, but there should be some communications coming out about that. The login nodes will probably be kept online for a while to facilitate that, but I don't have the details of the dates for that in particular. But yeah, your project data, your home data should be accessible transparently through the new system as well as the old system. So your files there won't change. I think the big question will be Scratch. What's going to happen to my Scratch data? And I think there's some communications that they're working on to let users know what's going to happen. They might migrate it, but more likely they'll say, hey, back up that Scratch and start using the new one. So that might be one of the things that needs to happen. But I think for Cedar, the Scratch was already decommissioned, the old one. So the new Scratch is already in place. So technically, I don't think anything should happen. I haven't checked out Rorcal yet, what they did with that. But I think there'll be a communication regardless, like your stuff just won't disappear. So don't worry about that particular aspect of it. But I think for Cedar, Fur, it's already done. For Rorcal, yeah, I can get back to you. I can check what they're doing with that. But if there is a need to migrate anything manually, there'll definitely be a communication if you're a user of one of those systems. But for project and home, for sure, you won't have to migrate. They'll do that migration for you. So hopefully that answers that question. But if there's any follow-up, and we need to make a follow-up, I mean, get in touch with us if you're concerned about anything, and we can get in touch directly with the sysadmins of those systems and see what the process and the status is if you have any worries about what's going to happen. But regardless, I wouldn't worry. The data will be kept secure. I think Cedar is done with Fur. It's using the same backend storage now already, but for Rorcal, I would have to check. Okay. Yeah, if there's any follow-up, just let us know, and we can definitely do a one-on-one and address any concerns. Right. So for cloud, yeah, it's IaaS. Most use cases can be satisfied by the clusters, just submitting jobs, things will run, you're all good. But if you do need to do something custom, you need to have a web service, database service, et cetera, cloud is a good opportunity. And then I guess one other advantage of the cloud also is because it's event-driven, the resources are always allocated to your account. There's no queue wait time and so forth. Although the amount of compute on the cloud is significantly less than what you get on the HPC systems. Yes.
It's a question on Slido. So it's, is the national system more recommended than UBC Arc? Our lab has been using Arc already, but we have never used national cloud.
So I would say it depends on your use case, right? If you're happy using Arc sockeye and you're finding that satisfies your workloads and you don't need to go beyond that, continue using. I think we don't What we do recommend is people at least get familiar with the national systems because that platform is a lot larger, right? There's a larger amount of computational capacity available on that platform, especially through the rack. And the GPUs are newer now, so the hardware is newer by several years, and the amount of storage is greater. But that being said, it really depends on your use case. If you were saying you're running on sockeye, UBC Arc system, and you're satisfied with the performance, you're getting what you need out of it, and there's no caveat, by all means, continue using that. We don't recommend one over the other, but we do recommend that, sockeye in general, it's open to everybody, but initially the idea behind it was for early career researchers to have access to some dedicated capacity at the institutional level, whereas the national system was open for everybody. It's a little bit of nuance there, but I wouldn't say I recommend one over the other. It really depends on your requirements. But what I do recommend is, because the platform is available and it's available free of charge, to at least explore the possibility of using the national platform, because it's all available to you. See if it works, and at the very worst case, it just gives you more access to more capacity. That's the case. But if you have very large, in the instances where I would say, yes, you should use a national platform, one example would be if you have some GPU training that you want to do for very large language models. Definitely, I'd say use the national system because their GPUs are far newer and have far more memory than the ones on sockeye. But let's say you're only training small models and sockeye is fine, then go ahead and use that, right? So it really depends on what you're running, how much computation you need, and so forth. But I still recommend, hey, at least try to get familiar with the national platform because it's free, and it at least gives you another option, regardless of if you're completely satisfied with the UBC option. But yeah, the use case is, like, for example, the GPU use case, I said, hey, this might work better than the other. The other example I would say is for sensitive data. So the national platform, they don't make any guarantees or any warranties for the types of data that you can store in the system. Generally, very highly sensitive data that can't leave the institution shouldn't be stored on the national platform because the data sharing agreements are not made at the national level. I mean, if you're a PI, you would have to take responsibility for anything if that happens. If you say, okay, I'm fine, I can put it in the national platform, it's out of province or out of the institution, that's fine. But yes, let's say you had some data set that had to be at UBC in particular, then obviously the use case is you'd have to use the UBC systems instead, right? So I'd say capacity, capability, and the data sharing agreements, data sensitivity, you want to take all those into consideration before deciding on what platform you want to use. So hopefully that helps the question.
It's like a follow-up question. It's
Yeah.
like if a researcher or a lab, like they have some computational needs, should they start with the national infrastructure first, or can they go to ARC directly?
Yeah, I recommend starting with the national infrastructure just from a personal level, like, hey, start using it and get familiarity. A lot of the systems are fairly similar, right? They have similar types of software. The scheduling system is similar, so forth. Our recommendation is, yeah, right now, especially with the infrastructure renewal, start with the national platform and then also apply for the sockeye if you want to. I think that's always been the general rule that if you have specific use cases like the sensitive data, or you're early career researcher and you need greater capacity and you joined in before the rack competition started, then maybe talk to us about the sockeye. But we don't want to say don't apply for that. But I think, yes, at least try to test out the national platform and see if it meets your requirements. And then you can come to sockeye and see, hey, do I need additional capacity? But we're not saying, no, don't do that. You can have both. There's nothing wrong with that either. But I think starting on the national platform, if you're just exploring what works for you, I'd say that's a good place to start, especially now because of the refresh. Obviously, sockeye and the UBC resources will also be refreshed at some point as well. But right now, there's a little bit of a capacity discrepancy between the two. Yep. So one other interesting thing that's been developed recently because of the AI explosion. I mean, everyone's been using ChatGPT, doing AI. It kind of was like, funny thing about all that is we've been hearing about it for years, and around 2023, it exploded onto the scene in the general psyche of the world. So the Canadian government funded some systems called a Pan-Canadian AI Compute Environment. So these are systems specifically designed for AI researchers. So if you're an AI researcher and that's your field of expertise, and you have a faculty member who's affiliated with one of the main Canadian AI institutes. So the main institutes are MILA, which is in Quebec, the Vector Institute, I think that's Ontario, and AMI, which is in Alberta. So a lot of UBC faculty actually have affiliations with one of these institutes. So if they do have an affiliation with one of the institutes, you can get access to these PACE clusters. These clusters are interesting because unlike the general purpose clusters, they all have GPUs. So they're specifically designed for AI training and inferencing. So if you're doing research with that, this gives you a large amount of GPU capacity. And also, there's not contention for it from the general research community. It's specifically to the AI researchers, just to provide them with additional capacity to get their work done, right? So this is something that's available now. If you go into the CCDB, Michael mentioned CCDB, you can opt into these services as long as your PI is affiliated with one of these institutes and gain instant access to one of these systems. Especially if you're having trouble getting GPU capacity, these are pretty useful to have. And they were just deployed earlier this year, so the hardware is all brand new, state-of-the-art stuff. And finally, this one, I'll confess, I don't know a whole lot about this in terms of the modalities of using this, but Calcul Quebec, one of the regions that's a member of the Digital Research Alliance of Canada, they have a quantum computer called Monarch, or Monarch Q, which is a 24-qubit quantum processor. So this is available as well. There's probably, you would have to be in that field of quantum computing or have some use case to use this. There's a link over there that gives you more details on the specs and how to get access and so forth. But yeah, it's very interesting, especially if you're in this field. As I said, I confess to not having a huge amount of knowledge on this, but it's a nice experimental system that does very specific things in quantum computing. It's kind of nice that there's an option at least available for that. And yeah, I mean, honestly, if you haven't used an Alliance system and you're either online or in the classroom, you can apply for an account anytime. And it takes about a couple of days max for the account to be processed. And once it's processed, you have instant access to these resources free of charge, which is pretty amazing, that researchers have, fairly easy on-ramp. You don't have to write a proposal or a long document to get access to these resources. It's as simple as applying for an account and then getting some capacity. So there's a bunch of documentation. They've written a really good volume of documentation available for using these systems because they can be complex. And we generally recommend, hey, go through the documentation. There are a bunch of training videos as well, self-serve training as well on how to use Alliance systems and provided by our partners. And I'm sure UBC ARC at some point in the future will also have our own self-training courses. So there's several materials available. And of course, as always, if there's any issues using these systems, you can contact us and we can sit down with you one-on-one and show you how to actually use the system. So a lot of resources, both from the technical and from the consulting side, are available. So that's the main bulk of the services that are provided by the Alliance: the HPC clusters, the cloud computing systems, documentation, technical support, et cetera, et cetera. There's a bunch of other stuff right after this, which are more, I would say, supplementary services. Maybe I'll just stop for a second and see if there's any more questions on Slido. Oh, good. So the other service that's kind of useful, and hopefully there'll be an expansion to this service coming over the next year or so, is Nextcloud. So Nextcloud is a really simple service. I'm sure a lot of you guys have used services like Google Drive, OneDrive, Dropbox. So this just provides 100 gigabytes of free storage with your Alliance account. You install the Nextcloud client on your PC or your Mac, and it also has a web interface, just a drag and drop file storage service. So if you just want to share a small data set with your researchers in your lab or folks outside the country or wherever Nextcloud is available. It's secure, it's hosted at SFU, so if you need something in province, it's in Canada. There's data sovereignty requirements and a bunch of stuff now. Super useful, nothing fancy. You all probably have used something similar before, but it's kind of nice that it's located here in the province, and it's really easy to use. The other service that Alliance provides, but this service is also provided by UBC ARC, is Globus. And Globus is a file transfer and sharing service. Very useful if you have a large amount of data that you want to move across systems. So let's say, one of the questions was, should I use Alliance or UBC ARC resources? Well, if you have accounts on both, you can actually transfer large quantities of data between these two systems using Globus, because Globus makes use of parallel file transfer techniques. So transferring terabytes of data, hundreds of gigabytes of data, is fairly simple and fairly quick using the data transfer network that we have. So super useful. You can share data. I have a specific data set I want to share with researchers somewhere else. I can restrict access to who I want access to the data, and those people don't need to have an Alliance account to gain access to the data. They just need a Globus account, because Globus is not just used by the Alliance and UBC ARC. It's used by pretty much every other research institution in Canada and the US and pretty much the world as your file transfer and sharing service. So lots of HPC sites, lots of cloud sites use this software. And I think there was a Globus, Michael might have taught a Globus class yesterday, so super useful service. And then there are a few miscellaneous type of services beyond the computing and the data, because Alliance is not just a provider of advanced research computing and cloud computing and clusters and so forth. There's a bunch of other things that they do. One of the big things that they do is research data management. Now, ARC in particular, we have some support for research data management in conjunction with the UBC library that does a lot of work in that regard. But the Alliance actually has a lot of dedicated resources and network of professionals for data management. So there's something called DMP Assistant. And I think this DMP Assistant maybe is even required in some cases to develop a data management plan when you're submitting proposals. So DMP Assistant is there, and it walks you step by step, kind of has a wizard for generating this data management plans. Further is another great service, and this service actually runs on the Alliance Cloud, but it's managed by a team of experts led out of the University of Saskatchewan. And it's a nice data repository. So let's say I have a data set my lab is producing. I can actually submit that curated data and the metadata to further submit. There's no real capacity restriction. And the nice thing about it is it'll be indexed. Metadata will be added to a search engine. And you can search for this data and provide this to the Canadian research community. There's also a geospatial search that they introduced a while back. I think it was called Geodesy. They might have changed the name. But yeah, it's pretty cool that you can just submit data, any type of unstructured data set with some metadata, and have access to it through this interface. So really, you don't need to manage that service. It's provided by the Alliance, and there's no technical complexity for the end researcher. Yeah.
Question from Slido. So does the infrastructure also provide access to TPUs, tensor processing units? Also with the infrastructure upgrade, how convenient would it be to access GPUs?
Yeah, so TPU, I have not heard that they're providing the TPUs. I'm assuming that the TPUs that are being referred to are the ones that are provided on GCP, like the Google Cloud. I've not seen in the infrastructure renewal that they're providing TPUs. But what is provided in terms of, so the question is convenience. I'm going to take that as a two-part type question is it going to be easy to access GPUs? So the ease of use it's not that difficult, like you submit a job for a certain type of GPU. And the GPUs, they're either going to, the H100s, I think, are the primary ones that are coming, so the NVIDIA H100s. There might be some L40s as well for inferencing workloads. But primary GPUs are fairly large. They will be split up. So they're using something called multi-instance GPU, which is taking a large GPU and sharding it into some smaller GPUs. The specs are available on the infrastructure renewal site. And the reason why they're doing that is because it's very hard for most jobs to make use of a single GPU efficiently, right? So this is to increase the availability of the GPUs to a larger number of researchers. So the GPU capacity has increased, but as Michael showed you in one of the slides earlier, it's still 30% of requests were fulfilled through the rack. So there's still a shortage overall in terms of the capacity. So what I would say is, yes, is it easy to access? Yes, you can submit a job and eventually your job will run. But the problem is always capacity and contention for the same resource. If you have 100 people requesting the same types of GPUs to run their training or inferencing workloads, your job is going to sit in the queue for a while. So how do you get around that? Well, one way is to write a nice proposal for the rack and ask for some dedicated amount of GPU capacity. Even that doesn't solve the problem entirely because, as Michael showed you earlier, only 30% of requests were guaranteed. That being said, yes, the situation is better than the current situation where we have older GPUs, which are the V100s and the P100s. Most of those, some A100s running, and those are previous gen stuff that doesn't have enough memory to handle large models, and also the numbers were much fewer. So the answer would be it's a qualified yes. Yes, they will be easier to access simply because there's more capacity and the new GPUs are a lot faster. So hopefully your job should run faster as well and not require as much wall time to run. The negative to that will be is because there's such an explosion in demand for GPU because the research cases are expanding, and you've seen with AI, it's such a tremendous demand for it that only time will tell that yes, if the current number of users and the requests stay the same as on the old systems, yes, it'll be easier to get access to the new GPUs. But as you know, folks are constantly finding newer and innovative use cases for these GPUs. So more people using them, more demands. So what are ways to alleviate it? One is through the rack. The other way is if you are an AI researcher, I mentioned those PACE systems. So if you have a PI who's affiliated with one of the national AI institutes, you get dedicated access to GPU-specific clusters, Killarney, Tamiya, and Vulkan. Those are the ones there. Only caveat there is your PI has to be a member of one of those AI institutes to get access. At some point, I think general access will be enabled for a specific select group of AI researchers that are not affiliated with institutions, but that hasn't been decided yet. So those are the answers. And I want to apologize for giving you answers that are nuanced or maybe a not yes, no answer, but it's still a little bit of a situation. The other thing I would say is if you can run your workloads on CPU, yes, CPU is never going to be as fast as GPU, especially for training and inferencing. But these new CPUs do have some capacity for AI as well. They're a lot faster. So if you're running smaller, working on smaller data sets, smaller models, you might be able to get away using CPU. And the amount of CPU capacity for the first time is in surplus. So that's one option as well if you just are running smaller jobs. So it's kind of the lay of the land, as it were. All right. The other service, yeah, so this is the one I was talking about. It used to be called Geodesy, I think, and this provides a search interface for finding data deposited in various repositories. So it's a national data discovery service, and I think there's a spatiotemporal index that it has, so you can search for data using that geospatial interface. So it's kind of cool that they have this. If you're looking for any sort of data, yes, highly restricted data sets won't be there for obvious reasons, but a lot of stuff isn't, so it should be discoverable through this. And then another one, I don't know how they came up with all these creative names, but I think these names and these logos are awesome that they came up with. It's called Borealis. And this is a Dataverse repository. So Dataverse is a particular type of platform for storing research data. The UBC library has their own Dataverse instance that's deployed at UBC, but this is a national research data repository. And then libraries. So yeah, I definitely recommend, even though we're ARC and we do some RDM, the university library has actually an RDM librarian that's dedicated for that purpose. So definitely have a chat with them if you're interested more in the RDM stuff than the ARC stuff. But you can always talk to us first, and we can bring the experts in to discuss your various project requirements. And yeah, so this is kind of like a self-promotion slide here, the training and education. So it's not just ARC doing the training and education for Alliance resources and general HPC and cloud training, data management training, and so forth. The Alliance itself has a very comprehensive training program for both general and domain specific, like bioinformatics, digital humanities, and so forth. There's actually a website that was just launched this year. It's called explora.alliancecan.ca, and that actually is kind of a search engine for all the training opportunities available across the country for free training in the field of HPC and cloud, research data management, and so forth. So it's kind of like a search engine that's constantly being updated and amalgamates all the training resources that are available. There's also just the link on the wiki that shows you what training is available. And the nice thing is, in the past, you had to wait for certain summer schools to start. Like this ARC summer school is one of the many summer schools that's being held or has been held across the country. There was the Compute Ontario summer school, Calcul Quebec had one, ACENET in the Maritimes had one, in the Prairies, University of Alberta had one. But there's actually a calendar there. You can look at the calendar, see when things are coming up. And the nice thing is, let's say you can't make one of these training programs, like recordings are available, but there's also a growing curated list of self-service courses. So stuff like Introduction to Linux, Bash Shell, Python, HPC, and so forth. They're all self-contained modules that are available now that you can go and use anytime. Doesn't have to be in the course time. So you can do that anytime you like. And I strongly recommend checking those out as well, because if you want to refer to something outside, I mean, we get 2 hours with you for each course, but you want to spend more time learning a particular topic, these self-service courses that are being developed are very useful. All right. And yeah, I think this might be the final slide, but very useful links. And I think the two most useful ones, the first one is arc.support@ubc.ca. So if you need support, anything Alliance or ARC related, if you send it to arc.support@ubc.ca, that's us essentially, we'll find a way to answer your query, whether it's an Alliance specific or an ARC, UBC ARC query. But there's also a way to contact the Alliance directly, which is the support@tech.alliancecan.ca. And that actually goes into the queue at the national level where folks from across the country will have access to your question. And there's a network of experts across the country that can look at it and say, hey, how do we help this researcher? So you have two avenues of contacting support. And yeah, definitely make use of it if you have an issue or you just want a consultation that, hey, I attended your training, but my problem is very specific, or I'm like the question we had on Slido. Maybe the researcher is not getting access to GPUs, even though they've tried and can't do their research. Come talk to us. Maybe there's something we can optimize or we can help you out and figure out what's going on. And yeah, documentation over there is very comprehensive, and we recommend people check that out. But we're always open, 24/7. We try to provide as much help as we can because our goal is to serve the research community. We're not general IT. My email stopped working. How do I fix that? No, we don't do that. Our goal is to facilitate research because that's what we were set up for by the VPRI. So yeah, don't hesitate. Just send us a message anytime you need assistance with this stuff. Yeah.
I'm not sure if you read this question, but the question is, if someone is having issues accessing GPUs, how effective will the UBC Sakai be in submitting jobs which require GPUs?
So that again is depending on the job. So UBC Sakai does have GPUs, but the GPUs are a couple of generations older at this point. So it's the NVIDIA V100. So those GPUs are also fair amount of demand. Maybe since I have Jacob right here, maybe I can put Jacob on the spot since Jacob was doing some scheduling in the past. Did you have maybe an idea of how the queue times were looking for the GPUs on Sockeye. Not obviously in comparison to the Alliance, but just in general, what was it looking like most recently?
So the queue times on Sockeye do generally depend on how many GPUs you're looking at utilizing. If you're using one or two, you can probably expect a job to be scheduled and run generally within an hour or like 1 to 4 hours, even at the busiest times. If you're requesting more than that, maybe a full node or multiple GPUs per job, you could be waiting to several days on trying to get space for that, just because it's a larger slice and we only have the 200-ish GPUs on our system.
Yeah. No, thanks, Jacob, for that actual detailed answer. Yeah, so it looks like, if you don't need too many GPUs, that's actually pretty good. A few hour queue time for GPUs is pretty excellent overall. But yeah, that multi-node, multi-GPU job, comparable probably to Alliance, maybe a little bit less queue time for a few days. But yeah, if you're just using one GPU and a few hours queue time, that's pretty good overall. The caveat is, yes, when those GPUs first came out, they were state of the art. The V100 has been out for a while, so you're restricted to 16 or 32 gigs of VRAM per GPU. If your problem size can fit into that, definitely make use of that. But that being said, when the new systems are fully operational, the queue time should be better than what you're currently experiencing now, because there's also been a capacity reduction in the existing systems as well while the upgrades were taking place, right? So you might notice an improvement in queue time. But as Sockeye is UBC specific and only UBC researchers use it, even though the system is pretty highly utilized, always about 90% or over utilization, it's still not a national system where you're competing with contention from the whole country, right, of researchers using it. So yeah, depending on the time of day and so forth, things can change. I will say one other point that I would add, and maybe I glossed over this point, is the Alliance Cloud will also be getting GPUs in September. So they'll be getting a combination of NVIDIA L40S and H100 GPUs. So those will be available at the cloud infrastructure level, which means there is no queue time, but you have to provide a good use case of why you need a cloud GPU that's always available versus something that you submit a job for. And I think the documentation of how to get access to that is still being worked on, but that's coming in September. If you have a good use case for a cloud GPU, that might be another option. All right. And yeah, there are no more questions. Feel free to interrupt me, Rachel, if there are any other questions. We have a 5-minute post-session survey. Maybe I'll pass it back to Michael just to take us home.
Okay. Thank you, Venkat. So yes, so we do have a survey. We would be so kind if you could give us some feedback on the session, on what you would like to see for training in the future. It'll take about 5 minutes, and you'll be put into a draw for a $25 Amazon gift card.
Michael will also stick around for a couple more minutes for questions. So if you have any questions, feel free to ask either on Slido or on Zoom or in person.
Thank you.